Hello, this is Mrs. Pullen for another video for the Chapter 5 Probability Review Sheet. In this video, I'm going to start by going over problem number 19. For flights from an airport in January, there's a 30% chance of the flight being delayed because of icy weather. If a flight is delayed because of icy weather, there's a 10% chance of the flight also being delayed because of the mechanical problem. So I see that like one thing is branching off of another, and that's why I think that this most likely is a tree diagram problem. And so I start with my branches. So I am told that there's the probability the plane's going to be delayed due to ice is 30%. So therefore, the probability it's not going to be delayed for ice, and I'm going to use that complement notation, is icy or 70%. Now, from that, I'm given more information. So I'm going to set up my branches. I'm told that if it's delayed because of ice, there's a 10% chance it's delayed for mechanical. So I'm going to have M for mechanical. So M given ice is equal to 10%. So therefore, the fact that it's not going to be delayed for mechanical, but it's delayed for ice is going to be the complement of that, so 90%. I'm also told that if the flight is not delayed because of the ice, so that would be this second branch over here, there's a 5% chance it's delayed for mechanical. So mechanical, if it's not delayed because of ice, so that IC, and that's 5%. So that means the probability it's not delayed for mechanical, given it's not delayed for ice, is the complement, so 1 minus 0.05 or 0.95. So now I want to find the joint probability, so I'm using that general multiplication rule. So I'm multiplying 0.3 times 0.1. So let me get my calculator out. Though I should know how to do this by heart, and I do. I just don't want to make a silly mistake. So that's 0.03. And now I want to find the joint probability that it's not delayed for mechanical, but it is delayed because of ice. So that's 0.3, make that point more clear, times 0.9 or 0.27. The probability that it's not delayed for ice, but is delayed for mechanical is 0.7 times 0.05. That should be 0.35, but again, I don't want to make a I would have made a silly mistake. It's 0.035. And then finally, the fact it's not delayed because of like MC given IC really means I'm looking for the joint probability. It's not delayed for anything, which is always what we want. And I hope if you're flying out this Thanksgiving that you have no delays. And that's 0.665. And I always double check myself. If I've done it correct, I should be able to take the 0.03, the different branches, 0.27 plus the 0.035 plus the 0.665, and that should add to 1, which it does. That's always a good sign. So now let me read what it's asking for. If one flight is selected at random from the airport, what is the probability that the flight selected will have at least one of the two types of delays? So this problem's a little different. It's not asking for conditional probability, just it's asking probability at least one delay. A little bit different than problem 20 and problem 18 that we've done before. So you're really just adding all the delays up. So the 0.03 plus the 0.27 plus the 0.035. and you get 0.335. We could have also done 1 minus 0.665 and gotten the answer as well. And so that's choice B. Problem 21. Gabriel has determined that if he gets to the bus stop at 7:30 a.m., there's a 15% chance that he'll miss the bus. If he's at the bus stop 3 consecutive days at 7:30, what is the approximate probability that he's going to catch the bus all 3 days? Well, each day is independent of each other, so therefore we could just multiply the 3 days together. But be careful. The information they gave you is the probability he misses the bus, so that's 0.15. So the probability he does not miss the bus, so miss C, is 1 minus 0.15 or 0.85. So you could use the slot method. It's one of the many ways you can do it. So this is day 1, day 2, day 3, or 0.85 raised to the third power. And that's 0.614, so choice D. We did problem number 12. Make sure you take another look at this. 22. We've done that in a prior video, but we haven't done 23. The guidance counselor at a large high school reports that 48% of the junior pre-calculus students signed up to take AP Stat next year. 52.5 decided to take Calc next year, and 10% of the pre-calculus students are taking both. So if one junior from pre-calc is selected at random, what's the chance they did not sign up to take AP Stat or pre-calc? So there you can do this Venn diagram many different ways. What I'm going to do is I'm going to use the OR formula, or the general addition rule, and I'm going to find out the likelihood they took pre-calc, AP Stat, or both, and then I'm going to take the complement of it. You don't have to do it this way. This is just one of the many ways of doing it. So AP Stat or AP Calc is equal to the probability stat, I'm going to shorten this, plus the probability calc minus the probability of both. So that's 0.485 plus 0.525 minus 0.1. And I'm going to enter that in. And I get 0.91. And notice they gave you that as a choice. It's a distractor choice because you want to find the probability they don't take at least one of these courses. And so did not sign up for either, for neither, for neither. And so that would be 1 minus 0.91, which is 0.09. And again, you didn't have to do the problem this way. It's just, I think, a little more straightforward, but that's up to you. You could do a Venn diagram as well. 24, a test has 10 multiple choice questions, each with 4 possible answers. So it's multiple choice test with 4 possible correct answers. You're supposed to design a simulation to estimate that the probability of a student answering at least 3 questions correctly out of 10. They're 10 multiple choice questions. Which of the following would be an appropriate assignment of the digits of a random number table to accomplish this task? So you're simulating a 10-question task, but what you're trying to do in this simulation is you have to simulate, there's only one correct answer out of 4. So the chance of getting an answer correct is 0.25. So you're really trying to simulate this for each question. So you want to have 1 out of 4 correct. So let's look at choice A. And again, take a look at simulating each question correct first, and then I'll explain the rest afterwards. So here you're choosing 0, 1, 2 as the correct answers and 3, 4, 5, 6, 7, 8, 9 as incorrect. Well, that's 3 out of 10. Well, that doesn't work because that's 30% and not 25%. So now I take a look at the other, and this is even worse because now we have 0, 1, 2, 3, 4. So that's 5 out of 10. So that's 0.5. So that doesn't work. That's not 25%. Choose the number 0 to rep the correct answer out of 1, 2, 3, 4. Well, that's looking good because that's 1 out of 4. And so that would simulate getting each question correct. And then we're going to ignore the other digits from the random number table. So this looks like a possibility. Choose 0, 1, 2, 3, 4. So that's 4 out of 10. So that doesn't work. Choose 0 out of 25. So that's 26 numbers because you're counting 0, right? Out of 100. So that doesn't work. So choice C is the correct one. And I know that sometimes students get confused because of like the 3 out of 10. Basically, if you were doing the simulation for each question, you would use a row of the random number table and look at the 4 choices, like in the way we chose it, 0 to see how many correct in the 4. And again, you would have to ignore the other digits, and you would repeat that process for the 10 questions. Any case, hopefully this video is helpful, and I will see you tomorrow.